We did till acceleration.
Yeah.
We will start acceleration today.
We did up to speed and velocity.
Yes.
Did up to speed and velocity. So today we will do acceleration, right?
Velocity.
Yes, sir.
Yeah, acceleration.
So acceleration is related to velocity.
Okay.
Acceleration is related to direction. They who have the experience, I think all of you have the experience that you while you are riding a car, that time the driver is pressing the accelerator, right?
Yes, sir.
Yeah.
And also the
Accelerate the car.
driver is pressing the brake. So
Yeah.
when the driver press the accelerator, he wants to speed up the car. He wants to increase the velocity of the car, right? That time he is
Yes.
pressing the accelerator. So this Meher Afroz Mithila, then Abdullah Munaim. Who is Abdullah Munaim? Abdullah Mayed is Abdullah Munaim.
Yes.
Okay. So acceleration, when you concentrate in one thing, why we are saying velocity? Why not we are saying speed that moment? Because the driver is not pressing the accelerator for a long time. Maybe he is pressing the accelerator for 2 seconds, 3 seconds, maximum 5 seconds, this way, right?
A short time, sir.
Yeah, very short time. And for that very short period of time, the car's direction remains in the same direction, right?
Yeah.
Isn't it?
Yeah.
And for this reason, as the car's direction is in a uh, particular direction or particular way it's moving, that's why we are saying it velocity, not speed. Is it
Speed.
clear?
Yeah.
Is it clear why we are saying velocity?
Yes, sir.
Sir, I didn't understand, sir.
Okay. Thank you so much that you shared that you did not understand. Listen, when the driver is pressing the accelerator, he is not pressing it for a long time. Did you understand this?
Yes, sir.
Yeah.
He is pressing it for a short period of time,
Short period of time.
very small amount of time, right? So for that moment, it's more likely that the car goes in a same direction, right?
Yeah.
So the car goes in the same direction. That means it has,
Like car is not going right or left. It's
yes,
in the
yes.
same direction.
It's not changing the direction. It's not changing the direction. That means it has, it is vector quantity, right?
Yes.
So if it is vector quantity, that means it is velocity, right? It's not
Yes, it is
speed.
velocity. It's not speed.
Is it clear now, Anmol?
Yes.
Yes, sir.
Anmol is clear?
Yes, sir. Yes, sir.
Okay, so if it is clear, then we can go forward. Now, as the car is increasing the velocity,
Hmm.
it's with the increase of velocity, it's taking also some time, right?
Yeah.
There is some time going on. So he is actually getting velocity increase and time. In other way around, we can say velocity increases with time. Is it? Is it clear?
Sir, I didn't
Yes.
understand this part.
Okay. Look, when the driver presses the, for example, the car was stationary, right?
Yeah.
If the car was stationary, then what was the velocity that time? Zero, right?
Zero.
If it is not moving, that means it does not have any velocity.
Velocity is zero.
Velocity
No
is
speed.
zero.
I mean, no velocity.
Okay,
Yeah.
so after pressing the accelerator, in 2 seconds, for example, the car's velocity is becoming 5 meter per second. Okay, is
Okay.
it clear? So
Yeah.
the car's velocity was 0 meter per second. Now car's velocity is 5 meter per second, right?
Yes.
Yeah.
So velocity increases from 0 to 5.
5.
It was 0 meter per second. Now it's 5 meter per second.
5 meter per second.
And for this whole process, the cars needed 2 seconds. How much time?
2 seconds.
2 seconds. So we can now, apply this all things in this formula. We have the formula of acceleration. A equals v minus u by t,
T.
where v is the final velocity. Just now we got
Yeah.
it
That is
5
5.
meter per second,
Yeah.
and u is the initial velocity.
The
Just now we
zero.
got it at 0 meter per second, right?
Yeah.
And the time taken,
2
it is
seconds.
2 seconds. So can you
So
calculate
divided by 2.
so
Yes,
can
sir.
you calculate how much is coming?
So it comes in points, sir.
Huh?
0.5.
Point is how
For
much?
5 minus 0 divided by 2, right?
5
yeah, 5
minus
minus 0 divided by 2.
5
it's
minus
2.5.
0 divided by 2. So what is the answer coming?
5.
2.5.
2.5. 2.5 meter per second, right?
Yes.
Yes.
Or meter per second square, what?
Meter per second square.
Yes. Why meter per second square?
Because it is the SI unit.
Meter per second square. So meter per second square, why it's coming meter per second square? From this formula, if you observe, you see v minus u, it is change in velocity, right?
Yes.
And
Sir,
change in
velocity is meter per second, right?
yes. So change in
So divided by seconds, so meter per second
yes,
square.
yes, correct. So meter per second divided by second is coming meter per second square.
Meter per
So
second square.
is it clear how this meter per second square is coming?
Yes, sir.
Yes, sir.
Yes, sir.
So we got the idea of acceleration.
Sir, it is 5 meter per second minus 0 meter per second, then divided by 2 seconds.
Divided by
That is
second,
why
2
meter.
seconds.
Yeah.
So,
That is why meter per second square.
so you got the uh, example of acceleration, right? Numerical example.
Yes, sir.
ভাবিটিকে দেখ
Okay. Now, if we are doing opposite, like a car, the car was moving, it had the speed or velocity. It had the velocity, for example, 5 meter per second, and the driver now wants to stop the car. Okay, there is traffic signal in front of the car. There is traffic signal. The car wants to stop, right? So what the driver will do?
Sir, can you please say again?
Yeah,
He will press
the car was
Wait a
moving,
moment.
right? The car
Yeah.
was in motion, and it had one speed. For example, it is 5 meter per second, right?
Okay.
So the driver wants to stop the car because there is traffic
Okay.
signal in front of him. Then what the driver will do?
He will press the brake.
He will press the brake. So what is the purpose of this brake? To slow down the car, right?
To slow down the car, yeah.
First the car will slow down, and slowly
Then it will stop at the
decrease the velocity. There it will stop. isn't it? So
But
this,
sometimes like drivers do hard brake,
yeah, sometimes it happens.
then
That
it
is
stops.
exceptional case, and that one also we
Yeah.
will get later
But
on.
usually it
When,
stops slow
yeah,
down.
yeah. So in this case, what is happening? Our initial velocity is bigger, right?
Yeah.
Hello.
Yes.
The initial
So
velocity
it's
now,
minus something, right?
yeah, the initial velocity
Initial
is now
is bigger. Bigger.
5 meter per second, for example, and the final speed or final velocity will be 0 if the car is stopped.
With 0 minus
Yeah.
5.
So, and the time taken, for example, now the time taken for this whole process,
Hello.
it is, uh,
Sir, can you explain the initial velocity?
again, please, anyone? Hello?
Someone was saying something.
Yes, Anmol.
Sir, initial velocity.
Yeah, initial velocity means the velocity it was before. Okay, so when the driver is pressing the brake, that means already we have some velocity, right? And for example, the initial velocity is 5 meter per second. How much it is?
5 meter per second.
5 meter per second.
Per second.
So if the car is stopped, then what will be the velocity?
0 meter per
Zero.
second.
0 meter per
0.
second. So for this slowing down process, or for this uh, stationary to come to to stop or rest position, the car required 4 seconds. How much time taken?
4 seconds, sir.
4
4
seconds.
seconds.
So what will be the acceleration that time?
Sir, 5 minus 4 divided by 0.
Is it 5 minus?
0 minus 5
Sorry.
divided by 4.
5 minus 0 divided by 4. Sorry.
Okay,
Yeah.
listen, Batsha. Our
Sorry, sir. Sorry.
formula we have to keep the way it is.
We can't
Okay,
change
Yes.
it.
in this case, our initial velocity is bigger.
No, sir. Sir, I know the formula, but by mistake I
Sir,
said
can you tell
it.
the initial velocity again,
The
sir?
the
Initial velocity.
initial velocity is 5 meter per second.
Yeah.
Got it? Anmol, you got it?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
And the
Initial.
final velocity is 0 because the car is stopped. And the time taken is 4 seconds.
4 second.
So
So answer
how
is
can we
1.25
calculate it?
meter per second square.
We can calculate it, right? Using this formula.
Yes.
The formula already we have. So A will be here 0 minus 5, then divided by 4, right?
Yes.
Then what is the
That is
answer coming?
Yes.
1.25 meter per second square.
It will be minus, right?
Yeah,
Minus
minus
1.25 meter per second
Minus
square.
1.25
Meter
meter per
per second
second
square. Per
square.
second square.
Look, in this case, we have minus sign, right?
Yeah.
So
Yes.
during,
Plus
Yes.
5 is bigger.
yeah, during slowing down or during the deceleration process, the slowing down is also known as deceleration, opposite of acceleration. Can you please note down it?
Yes.
Note down it in your copy that,
Sir, can you write the spelling, sir?
yeah,
The spelling.
I'm writing. Slowing down is also known as deceleration. It is also known as retardation. Yeah, during your study life onwards, from now on, sometimes you will get retardation, sometimes you will get deceleration,
Deceleration.
sometimes you will get slowing down. All these are same thing. Okay, so deceleration is opposite of acceleration, right?
Yes.
Deceleration is opposite of acceleration. And
Acceleration.
look here, we are getting
Acceleration.
negative, right? Negative, right? In
Yes,
our
sir.
answer. So can we say that deceleration is negative acceleration?
Yes.
Can we say deceleration is negative acceleration? Is it clear, everyone?
Yes, sir.
What about others? Are they clear?
Sir, why we will not write 5 minus 0?
Because our
5 is
initial,
the
Initial
initial
velocity
velocity.
হচ্ছে -5
Wait,
আর
let's search.
finally
Let's
0.
search. Let's search.
okay, okay, look, our formula is A equals V minus U by T, right? And
Yes.
V is here final velocity, U is initial velocity. So when the car
Okay.
is slowing down, that time final velocity is 0
Okay.
as the car is stopped.
Okay.
And the initial velocity was bigger. It was 5.
Oh, yeah.
During slowing down, it is opposite process.
Yes.
Is it clear now?
Yes.
Okay. So if it is clear, then can we go to next part?
Sure, sir.
Okay. You
Yes.
see, we got another point. If the velocity of object is constant, the acceleration is 0.
0.
If the velocity is constant, for initial velocity and final velocity, we are getting
Like,
the
is
same
it in
value.
a constant speed?
So we are getting the same value, right? For V and U, that time if the velocity is constant. Is it clear, everyone?
Yes.
So if the velocity is constant, if you calculate,
Acceleration
it's
will be 0.
coming 0 by T. That means the acceleration is 0. And
0.
from the definition also, we understand that uh, acceleration means increase in velocity, right? If the velocity remains same, then there is no acceleration. Is it clear, everyone?
Yes,
Hello?
sir.
Yes, sir.
Yes, it's clear. Now we are going for two terms here, new terms. You see, one is uniform acceleration, another one is non-uniform acceleration. For this one, I am showing you one graph, then you'll understand it. Look, if we are getting a graph like this, here is, can you please also draw and take these notes the way I'm doing? Here we have time. Here is time. Time is represented by T and velocity V. Okay. So if the motion of the car or motion of the object is like that, after each of the second, for example, when it is 1 second, the velocity is 2 meter per second square, 2 meter per second. After 2 second, it is 4. Then after 3 second, it is 6.
It
Okay.
means, sir, it
So
is increasing in a constant manner.
yes, it's increasing in a constant manner. That means every second the velocity is increasing by 2 meter per second.
Increasing by 2. Yes.
Yeah. So if you plot this graph, that time we'll get one straight line like this. Okay. I am getting the points. If you add this all point, then you'll get a straight line. So this type of graph, we are getting uniform acceleration. Do you understand? Hello.
Yes, sir.
Yes, sir.
Uniform acceleration, sir.
So please, you draw this graph and here you write uniform acceleration. Why uniform acceleration? I'm writing. Please, you also write uniform acceleration. Uniform acceleration. So uniform acceleration means rate of increase of velocity
In a constant.
is same. We are making it simpler, huh? Same. We can say same. We can say steady. We can say constant. The one you say. Is it clear?
Yes,
Is
sir.
it clear? And the
Yes,
value
sir.
also I write here. That is 2 meter per second square. From our graph we get this one. So is it clear now, everyone? Hello.
Yes, sir.
So please take these notes. Then it will be in your mind clearly. You will never forget it. Okay. Now we are having another example. Like if you have uh, a motion of car like this, we have here velocity and time. Here is velocity and here is time. Now, if we are getting a graph or the values this way, after 1 second, the velocity is 2 meter per second. Then after 2 seconds,
4.
no, you don't write. You don't say anything and don't write. I am showing you. Wait, just wait. Huh? After 2 seconds, it is 5. Then after 3 seconds, I'm writing here 3. You also write, please. After 3 seconds, for example, it is 9. Okay. So if you are getting this way the graph, then what will happen? You will get a shape like this. Okay. So this one is showing you rate of increase of velocity is increasing. It's not constant, it's not steady, it's not same. Okay, so this one is called non-uniform acceleration. Non-uniform acceleration. Are you taking the notes, everyone? Why it's non-uniform? I'm writing also that one. Rate of increase of velocity increases. Is it clear, everyone? Hello?
Yes, sir.
Yes, sir, it's clear.
It's clear. Okay, very good. Now, it might be of another shape. We can also get another shape. I'm showing you. Like, here you see.
Sir,
We're
we
having
can't see,
another
sir.
one.
It is
V
rate of
rate of increase of velocity increases.
What?
Rate of increase of velocity, you can see now, right?
Yes, sir. Now clear.
Now it's clear. Okay, very good. Now look, we are having another shape, like we can have also uh, the third one, the shape like the third one I'm showing you. Look, we can have also this shape. This time I'm not giving you the values, just showing the shape. So this one is also increasing the velocity, right? It's also increasing the velocity, but
Yes.
the curve is not like before. The curve is going little bit less steeper. Okay, so this one, the velocity is increasing, but the increasing rate is less. So that one is also non-uniform acceleration. So this one I'm writing here, rate
Sir,
of
this one is uniform acceleration,
non-uniform.
non-uniform.
This is also non-uniform, but here what
Sir,
happens,
can
rate
you
of,
explain why again? Sir, not clear.
yeah, I'm showing you. Look here, for each of the second, if you see with time increasing, the rate of the velocity is not increasing with greater rate. It's increasing, but not like this one. It's increasing, you see, first this one increases 2, right? Then 3, then 4. Maybe this one is increasing like 1.5 or 2.5 or only 2, this way, right? Little increasing. Is it clear?
Hello.
Is it clear now, Anmol?
Yes, sir.
So I'm writing it. You please also write rate of increase of velocity decreasing.
Decreasing.
Yes, you see rate means like if in 1 second it is 2 meter per second.
Sir, maybe it is going on point 0.5 to point
Yes,
0.5
yes,
like this. That is
little
why the curve
increasing.
is.
But
Yeah.
rate is decreasing. Rate of increase. Rate means,
Rate is decreasing. Yeah.
yeah, rate means with
Rate of.
time. With
Yeah.
time, the increasing rate is decreasing. That's why it is also non-uniform acceleration. Is it clear?
Yes, sir.
So please draw all these shapes and this information so that later on we can understand easily. If you are done, then we'll go to next part. Let me know that you are done.
Sir, done.
Okay. If you are done, then we are going to next step, because these are, sometimes students becomes puzzled, they messed up. That's why you should be very careful about this all
Sir,
things. Now look, Badsha Fahad, you are
Sorry, sir.
annotating a lot.
By mistake. Sorry.
Okay, you are
Sorry.
annotating
Sorry.
a lot. Okay, look here. This one is not speed time graph. The graph is shown here. You look, this one. This is distance time graphs. Okay, so this graph is showing you acceleration, is showing you constant speed, is showing you slowing down, is showing you stationary.
Stationary.
Stationary means the object is in rest. See, the time is increasing, but the distance remains same. That's why we can
It
say
is in
the,
stop.
yeah, we can say stop, we can say rest, we can say stationary. And distance time graph, we are getting the speed, constant speed. If there is one straight line like this,
Sir,
don't mix up, don't mix up with distance time graph and speed time graph. We are going for more discussion with that one. Just you remember that distance time graph, if it is at constant speed, then we have a straight line like this. It's steeper straight line. And if it is accelerating, then we have a curved line. If it is slowing down, then it is with
Curve line.
decreasing gradient, curved line with decreasing gradient. If it is parallel to time axis, a straight line, horizontal to time axis, that is stationary. Yes, Anmol.
Sir,
Yes,
sir,
Anmol, tell
over
me.
here, sir, over here it's slowing down, right? The area that I
Not
marked.
not all the things. From here, slowing down
till here.
starts, and till here it is slowing down done. Then after that the car is stopped.
Oh, okay, sir.
Sir, can I say something?
Yes,
Okay,
sure.
sir.
Sir, their acceleration, that is why it will be curve with increased gradient.
Yes.
And there
Increasing
is
gradient.
constant speed, that is why it will be straight line.
Look, this one,
This whole line, sir.
this okay, this line is also showing you increasing gradient. This one is also showing you increasing gradient, right?
Yes.
Hello. But this one has constant gradient for this whole process, right? You see, if you take the ratio of distance over time, everywhere you'll get the same. Okay, that's why this one is called constant speed.
Yeah.
You
Because
got
sir,
the
it is
Straight
gradient
more
with
here.
steep.
You
increased
got the,
gradient curve.
yeah. You got the
Sir, can
gradient
you
here.
explain constant
You-
gradient?
Yeah, you got the gradient here. It's slowly increasing, right? And finally here is coming most gradient, right? And for this process, the line starts from here and till here. We have the gradient more than this part, isn't it? Hello?
Yes.
But
Yes.
this part, everywhere we have the same gradient. If you calculate with time, you will get always same gradient. That's why it is called constant speed. Is it clear now? Hello?
Yes, sir. Yes.
Okay.
Yes.
Okay. So,
Error.
okay, now it's came again, right? Look, we have some points here. Just now, whatever we discussed, we are just getting the summary of all these discussions. Look, for a distance time graph, the distance never decreases. You see, for this whole graph, the distance never decreases. Distance always increases. Okay? For the object is stationary, the distance time graph will be horizontal. We got here horizontal, right? Here stationary, horizontal. And the gradient of a distance time graph is the instantaneous speed of the object. That means gradient is giving you the speed. Distance time graph gradient is giving you the speed. The straight line with positive gradient, it means that the object is traveling at uniform speed. This one is straight line with positive gradient. It is giving us constant speed. There is no straight line with negative gradient. No negative gradient here in distance time graphs. For curves, it means that the object is traveling at a non-uniform speed. Non-uniform speed means there is acceleration. So it's done. Okay, everyone. Today we will continue after
Yes,
that.
sir.
In
Yes,
next
sir.
Okay,
class.
sir.
Bye bye, sir.
Allah
Inshallah, sir.
Hafiz.
Bye, sir. Assalamu alaikum, sir.